Alright, this is part 3 of the video, and in the previous videos we have created the VLANs on the switches, and now we're working on the router itself. We have created our sub interfaces on the router, but as you can see they are all down. uh, this is a really good question. Why are these interfaces down? You can go in and go into facet 0.0.30 and turn it on, but it will not turn on. So I'll show you what I'm talking about. So if I wanted these interfaces to come up, and I went to zero dot zero zero dot 10 and I said no shutdown, it's not gonna do anything. If I did show IP interface brief, that interface is still down. Why is this so? This is because this is actually not a physical interface, it's a sub interface of the fast Ethernet 00 interface. So to turn these interfaces on, the physical interface has to be on. So watch what happens whenever I turn fast Ethernet 00 on. As you can see, the LAN protocol is up for all these interfaces, and let's confirm that. Now LAN protocol is up and status is up for these interfaces. So you got to remember, you create the sub interfaces, which are like virtual interfaces if you would like, on the real interfaces, and to turn those sub interfaces on, the physical interface has to be on it. It just makes sense. Okay. Alright, so now we have done that. We have configured IP addresses and sub interfaces that we like. The other thing that I need to point out to you is that every host over here, this is in VLAN 30, this host is in VLAN 30, his gateway is supposed to point to a sub interface that is in that VLAN on that router. Okay, so VLAN 30 has to have a gateway that is that. VLAN 20 host will have to have a gateway that is pointing to that on VLAN 20. VLAN 10 computers will have to have a gateway pointing to the sub interface that. Why is this so? Because this computer is going to try to come. Let's say if this computer was trying to communicate with any computer in this VLAN, it's not going to work. So it's going to traffic is going to get over here to the switch, and this switch is going to forward it to the router, and the router is then going to forward it back and say, hey, I know where that packet goes. It goes to this VLAN, and then push it to that VLAN. So we need to make sure that our gateway is pointing to the sub interface on the router, so that traffic that needs to go anywhere is going to be forwarded to that VLAN. Okay, so to be a little graphic, if VLAN 20 needs to send information to VLAN 10, he's going to send it to his gateway. It's going to go over here and it's going to go to the sub interface, because to this computer, he's in this computer's own mind, in this VLAN, he only knows he's directly connected to this VLAN. He does not know about these other sub interfaces, and so does all these other computers. So if that makes sense, then any traffic that is destined for another VLAN is going to go to the router. The router is going to make the decision on which VLAN is supposed to go to, because the router knows of all the 3 VLANs. So let's go in and see show IP route, and then you can understand what I'm talking about. So show IP route on the router, and the router knows routes to the 10.network, which is on VLAN 10. The router also knows routes to the 20 network, which is on VLAN 20, and the router also knows of VLAN 30, which is on the 30 subnet. So the router feels like he's physically connected to those 3 VLANs, but all on just one single interface. So now that we've configured this, what's going to happen, like I said, packets will go here. The router will route the traffic back to the switch, pointing it to where it needs to go, which VLAN it needs to go, because the router knows where it's supposed to go. So the only other thing is to tell the switch that, hey, if you receive a packet that you don't know where it's going to go to, you need to forward it out your fast Ethernet 01 interface. So essentially we need to tell the switch that it needs to have a default gateway off this interface so that anything that gets here gets sent out that interface. So the way we do that is create an IP route, and since we want anything to anything, we're gonna call the quad 4 0.0.0, saying that anything going to anywhere that you don't know about, send it out your fast Ethernet 0.1 interface, if you would. So now, if any traffic gets in here, instead of getting stuck, it will push it over here, and the routing decision will be made here, send back to the switch, and send back to the appropriate VLAN. So now we need to test our configuration. Of course, these hosts have been this is in VLAN 10, so I've given them IP addresses in the VLAN 10 subnet, and the gateway, like I said, is pointing to the sub interface on that router, which is in the same VLAN. Okay, so now we're going to do a graphical ping here. I'm going to ping from here to there. Of course, it will fail the first time. So we're trying to ping here, and we're getting failed. One thing that I forgot to do is, like I mentioned earlier on, this link must be a trunk to carry multiple VLAN traffic across it. Over here we've configured it to be .1Q encapsulation, but we have to do the same thing on this interface too. So I'm going to go in there and do that. Fastener 0.1, and we want to switch port trunk encapsulation. We're going to use .1Q instead of ISL. .1Q, and then we can call switch port mode trunk. Okay, now that we do that, this link is configured as our trunk, and we shall wait for it to come back up, and when it does, we will try to ping and see if it worked this time. Another thing that I mentioned earlier on, you do not need to configure an IP route on this router, because it's on the switch, because it's actually just a layer 2 switch, so you don't need to configure a static route or anything for a default gateway. Okay, now that that is done, all that we need to do is try to ping over here. That interface is up. Now that this is a trunk, we should be able to successfully ping the router. Okay, we can ping the router. So how about pinging from one VLAN to other VLAN? So from here to there. Of course, it will fail the first time. We'll ping one more time, and it's successful. So there we go, to there, success. And let's ping from here to VLAN 10. Progress. Oop. It failed for the first time because it's populating its routes. Let's see. And then it's successful. So from VLAN 30 we can ping VLAN 10. From VLAN 30 we can ping VLAN 20, and from VLAN 20 we can ping VLAN 30. So we can see that our configuration is successful, so VLANs can now route between each other, and this is handled by the router on the stick. I hope you enjoyed this video, and I will be making more, so feel free to subscribe. Thank you. Bye bye.